Hello everyone. Again, this is your junior high school math teacher, and in this video, I'll discuss about the trigonometric identities. Now, after you watch this, you should be able to simplify trigonometric expressions, apply simplification to prove the identity, and show appreciation in doing the assigned task with positivity and better outcomes. An equation which is true for any value in its domain is called an identity. A trigonometric identity is an equation that involves trigonometric functions. In proving trigonometric identities, we have to show that the expression on both sides of the equality are identical. Usually, we simplify one side of the equation by using the fundamental identities until it is in the same form as the other. Sometimes, we simplify both sides of the equation independently. We don't transpose any expression from one side to the other, and we don't multiply or divide the equation by any common expression. Now, for our next slide, let us now consider these so-called identities. Actually, these identities are grouped according to the following sets. The first one is reciprocal identities. Second, we have the quotient identities, and the third one is the Pythagorean identities. Now, under the reciprocal identities, we have the following. Cosecant theta is equal to 1 over sine theta. Next, we have secant theta equals 1 over cosine theta. And then we have cotangent theta equals 1 over tangent theta. So we have three reciprocal identities. Now, for the quotient identities, we have the following. Tangent theta equals sine theta over cosine theta. And cotangent theta equals cosine theta over sine theta. Now, for our third group of identities, the Pythagorean identities, we have sine squared theta plus cosine squared theta equals 1. 1 plus tangent squared theta equals secant squared theta. And 1 plus cotangent squared theta equals cosecant squared theta. So we need to put these things in our mind because on the next slide, I'll be presenting some examples on how to prove identities, and we're going to apply these three groups of fundamental identities. Okay, let us start with example number 1. So we're going to prove these identities. Letter A, cotangent squared theta equals cotangent theta times the quantity 1 over tangent theta. So basically, what we're going to do from this given equation or identity, we choose which of the two sides are to be simplified. Now, whatever the side we choose, we need to simplify that, and we make that side identical to the other side. So in this particular case, let us choose the right side, which is cotangent theta times the quantity 1 over tangent theta. So basically, we're going to simplify this, and we make this, the simplest form of this side, equal to the left side, which is cotangent squared theta. So solution. Okay, let us rewrite the given identity or the given equation. And we have at this point is cotangent squared theta is equal to cotangent theta. So we are about to replace the one inside the parentheses with its equivalent, which is the cotangent theta, meaning 1 plus tangent of theta is replaced by its identity, which is cotangent theta. So as a result, the left side will now be cotangent theta times cotangent theta. And we know that the result of multiplying two identical functions will be what? Cotangent squared of theta, which is right now the same as the one on the left side, which is cotangent squared of theta. So therefore, we have just proven this identity. Okay? Next, how about letter B? For letter B, we are going to prove that cosine theta is equal to sine theta times cosine theta cosecant theta. So again, just like what we did in letter A, we're going to choose one side to simplify, and when we simplify that chosen side, we need to find out if that simplest form will be equal to the other side. Okay, let us copy the given in letter B. So we decided to simplify the right side again. Okay? So for our first line of solution, we have cosine theta is equal to sine theta cosine theta multiplied by the equivalent of cosecant theta, which is equal to 1 over sine theta. So basically, we apply the reciprocal identity, which is cosecant theta is equal to 1 over sine theta. And at this point, we are going to cancel sine theta like this. And what will remain on the right side will just be the cosine theta. So at this point, we found out that cosine theta is equal to cosine theta, the one that is left on this side, because we have already canceled sine theta here. And again, just like letter A, we have just proven that this given equation is an identity, meaning the expression on the left is equivalent to the expression on the right, which is this one. Okay? Next, letter C. How about this one? Sine theta cosine theta is equal to sine squared theta cosine squared theta cosecant theta secant theta. Okay, again, we're going to simplify one of those two sides of the equal signs. Okay, so let us rewrite the given equation. And at this point, we are going to choose again the right side. So for our first line of solution, we have just copied this portion, and we are about to make a simplification on the right side. Okay, so we're going to replace cosecant theta by its equivalent, which is 1 over sine theta. And secant theta is replaced also by its equivalent. So basically, we're going to apply again the reciprocal identity. So, okay, secant theta is equal to 1 over cosine theta. So we're going to cancel sine here, sine squared, and then sine. Then likewise, cosine squared theta and cosine theta, because there is a common factor between the two. Yeah. And here, what will remain from this factor if we cancel the sine theta? Okay, here we have what will remain here is just sine theta, and same thing with cosecant squared theta, it will become cosine theta. And from here, since we cancel the common factor here, sine theta on the denominator together with cosine theta, which is also a denominator, become 1. So what will remain on the right side will just simply what? Sine theta, cosine theta, which is again at this point, we have just proven that this given equation is an identity. Okay. Yan. Next, about number 2. Now we're going to prove that 1 is equal to quantity secant theta minus tangent theta times the quantity secant theta plus tangent theta. So it's very obvious that we're going to simplify the right side again to make the resulting simplest expression equal to the one we see right now on the left side. Okay. So what we're going to do, okay, we could use the FOIL method to multiply the two binomial expressions. Okay. Okay, secant theta times secant theta. So this is the product. Outer terms, we get the product of these two. This is the result. Then minus, okay, tangent theta times secant theta. This is the product. Then again, minus tangent theta times tangent theta is tangent squared theta. Then we combine similar terms. Since the two middle terms are opposite to one another, they will cancel each other. So what will remain on the left side is simply secant squared theta minus tangent squared theta. Ayan. Okay, then we apply the Pythagorean identity, which is 1 plus tangent squared theta is equal to secant squared theta. So basically, this term right here is to be replaced by its equivalent. And what is the equivalent? It's simply 1 plus tangent squared theta. So that for our next solution, okay, 1 minus secant squared theta, which is right now replaced by its equivalent. So that is 1 plus tangent squared theta minus tangent squared of theta. And you will notice that these last two terms are the same, although they have different signs. So that these last two terms are opposite to one another. So if we're going to combine these two, they will cancel each other. So what will remain on the right side is simply 1. Therefore, as a result, the right side now is the equivalent of the left side. Okay? Again, we have just proven another given equation. Next, how about number 3? Okay, let us prove that 2 cosine squared theta minus 1 equals 1 minus 2 sine squared theta. Solution, again, rewriting the given equation. So again, we're going to use a Pythagorean identity here. Sine squared theta plus cosine squared theta equals 1. And from this equation, we transform this solving for sine squared theta. And that is equal to 1 minus cosine squared theta. So basically, what we're going to do is we simplify again the right side, which is 1 minus sine squared theta. So for the left side, we copy 1 minus 2, and then sine squared theta will now be replaced by 1 minus cosine squared theta because of this Pythagorean identity. Yon. Then distribute 2 to each term inside the parentheses. So the left side now becomes 1 minus 2 plus, okay, negative times negative is positive. So 2 cosine squared theta. And these first two terms can now be combined since they are both numerical terms or constant terms. So as a result, 1 minus 2 will become negative 1 plus 2 cosine squared theta. Or we interchange the terms so that the negative term will be written as last term and the first term should be the positive one. So it becomes 2 cosine squared theta minus 1, which is right now identical to the expression on the left side, which is this one. So at this point, again, we have just proven another given equation. So this is an identity. Okay. Next, we go to number 4. How about this one? Sine to the 4th theta plus cosine squared theta. Sine squared theta is equal to sine squared theta. For our solution, let us copy the given equation. So obviously, what we're going to simplify here is the expression on the left side, which is this one. Okay, so the expression has how many terms? There are 2 terms, 1, 2. And you will notice that from each of these terms, there is a common factor. And what is that common factor? It's actually sine squared theta. So ilalabas natin yung sine squared of theta sa bawat term. So that the left side expression will now become sine squared theta equals sine squared theta plus cosine squared theta, which is equal to sine squared theta. Now you will notice that the expression inside the parenthesis is now being replaced by 1 because this is an identity, a Pythagorean identity equal to 1. And we know that 1 times a certain quantity will result to the quantity itself. Therefore, at this point, the left side is now identical to the right side. And again, this equation is an identity. Okay. Next, we go to number 5. How about this one? Cosecant x, secant x equals quantity cosecant x plus secant x divided by cosine x plus sine x. Okay, rewriting the given equation. So what we're going to simplify here, obviously we're going to simplify the right side and make the right side identical to the left side. Yan. So what we're going to do, okay, so we factor out the expression on the numerator, which is cosecant x plus sine of x. We factor this out, and what will remain from this expression is what? This one, 1 over the quantity cosine x plus sine of x. Yan. Okay, dapat may parenthesis to, no? Okay. There must be a parenthesis here. Next. Yun. Then what shall we do? Using the reciprocal identity, we replace cosecant x by what? 1 plus sine of x. Same thing with secant of x. It is also replaced by 1 over cosine x. So plus 1 over cosine of x multiplied by this quantity. Okay, ayun. Then, what shall we do with the expression on inside the parentheses? We combine the 2 fractions by determining their LCD. So, what is the LCD? It's simply the product of these 2. Then, this LCD divided by sine of x will be equal to cosine of x times 1 is cosine of x. Then, the same LCD, this time we divide this by cosine of x. Magka-cancel ang cosine of x at ang matitira is sine of x. And sine x times 1 is sine x. Okay? And this quantity is again to be multiplied by this expression. Now, what have we noticed here? There is a common factor that can be cancelled. And what is that common factor? The quantity cosine x sine plus sine x here, and the same expression. Okay, so they are This is the common binomial expression, so we cancel them out. So what will remain here from this expression is simply what? 1 over sine x cosine of x. Now, again, using the reciprocal identity, this expression right here can be written as what? Cosecant x sine of x. So therefore, another identity is proven. Okay, so again, just like the previous examples, the equation in number 5 is also an identity. Okay. Next, number 6. How about prove that secant theta cosecant theta is equal to tangent theta plus cotangent theta. So solution. Okay, rewriting the given. So we choose which of the two sides is to be simplified. So here we simplify the right side. Okay? So tangent theta is actually sine theta cosine theta. So basically we apply what? The quotient identity. Plus, about the quotient identity of cotangent theta, that is actually cosine theta over sine theta. Then, we have two fractions with different denominators. So if we're going to combine these two, we get first the LCD. And the LCD is what? The product of these two denominators. So sine theta, cosine theta. Then, we divide this LCD to the denominator of the first fraction and multiply the result by the numerator. So this will become sine squared theta plus sine theta cosine theta divided by sine theta. What will remain is cosine theta multiplied by cosine theta, so the result is cosine squared theta. And you will notice that the numerator, sine squared theta plus cosine squared theta, is actually equal to 1. So basically, we are applying the Pythagorean identity in this numerator. So the expression here on this side is now 1 over sine theta cosine theta. Yun. And applying the reciprocal identity, 1 over sine theta cosine theta is equal to cosecant theta sine theta. Okay? Yun. Okay? So again, the equation in number 6 is again an identity. Next, number 7, probably this is the last one. How about cotangent x plus cosecant x secant x equals sine x over quantity 1 minus cosine x plus tangent x over quantity 1 plus cosine of x. Solution, rewriting the given equation. So basically, which of the two expressions, what we're going to choose here, what side are we going to choose to simplify? So we take the right side. Okay? So basically, what we did here is we get the LCD of these two fractional expression since they have different denominators. So we get the product. So if we're going to multiply this denominator by this denominator, the resulting LCD is 1 minus secant squared theta. Okay? And then, so if we're going to combine the two, so the numerator becomes what? Sine x times the quantity 1 plus cosine of x. Okay, not yet. No. So this one, when we divide by 1 minus cosine of x will have 1 plus cosine of x times sine of x. So this is the new fraction, which is equivalent of this one. Then, the same denominator divided by 1 plus cosine of x. What will remain is what? Cosine 1 plus or 1 minus cosine of x times tangent of x. So this is the numerator. Next. So since we have now common denominator, so we make the two denominators as 1. So 1 minus cosine squared of theta. And then, okay, so ano nangyari? Sin x is being distributed inside the parentheses. So if we're going to multiply this to this binomial, the resulting product would be like this. Then same thing, tangent theta multiplied by 1 and cosine of x. This is the result. Then we try to, okay, so 1 minus cosine squared of x is now replaced by sine squared of theta. So basically, we apply the Pythagorean theorem, okay, to replace 1 minus cosine squared of x by sine squared of x. Then, okay, rewriting the term, then tangent x minus tangent x cosine of x. Then what comes next? Okay, so each term on the numerator is being divided by sine squared x. Ayun. Okay? Then, ano mangyayari? Okay. So this term right here, we cancel sine of x. So it is now equivalent to 1 over sine of x plus, okay, we cancel sine x and sine squared of x. So this term will now be this simplest form, cosine x sine of x plus, okay, tangent x over sine squared of x. Ayun. Okay, tangent x is actually equal to sine x cosine of x, this one. So we apply the quotient identity so that we could simplify sine x here. Ganon din, yung tangent x pinalitan ng sine x cosine of x. Now, to continue with the simplification, okay, let us rewrite this expression right here to a more simpler one. Okay, so cosine x over sine of x is actually cotangent of x. Then plus, yun. So this term right here will now be equal to 1 cosine of x times 1 over sine of x. So this is 1 over cosine of x. Then minus, okay, if we're going to simplify this, ito na lang matitira, 1 minus sine of x. Then, okay, 1 over sine of x minus 1 over sine of x, so they will cancel each other. So ano matitira? Cotangent of x is equal to, okay, 1 over cosine of x is now replaced by secant of x. Then 1 minus sine of x is also replaced this time by its equivalent, which is cosecant of x. And at this point, you will notice that this simplest form is now identical with the expression on the left side. Meaning the last example, number 7, is an identity. Okay? Yun. Okay, so I think I have given you all the examples to this topic on how to prove an identity using those first three sets of fundamental identities. So if you don't have any question, we will see you next time.